Welcome viewers, welcome to the new lesson from Dr. Arts Biology. If you did not subscribe the channel, you can just click on the subscribe button and bell icon. Welcome students, hope the previous lesson is very clear for you. So you make sure that you have learned the previous lesson and then only you have to come to this particular lesson, otherwise as I told you before you will be having confusion. Okay, so in this particular lesson we will be just discussing the structural and functional aspects of different monosaccharides. Especially in this lesson we will be discussing the monosaccharides that comes under Triose, Tetrose and Pentose. The Hexose we will be discussing in the another lesson. So this topic will be covered in this particular lesson. So let us see first about the Triose sugar. So Triose you have to learn the two examples, glyceraldehyde and dihydroxyacetone, where the glyceraldehyde is actually an aldose sugar and this particular dihydroxyacetone is actually a ketose sugar. Okay, so let us see the structure of glyceraldehyde first. We know that glyceraldehyde is composed of 3 carbon. So we can just, you have to learn the structure because the structure will be asked for the examination. Okay, because the functional component is comparatively lesser for these lower sugars. So you will be asked to write the structure, draw the structure of this particular examples. Okay, so you have to learn how to draw the structure. Nothing to worry about this particular thing. You can just watch my video how to remember all the monosaccharides and then you will be thorough with whatever the question comes. Even if the example that is not there in your syllabus comes, you will be able to draw that particular structure. You can just watch this particular video. So you can see here glyceraldehyde is composed of 3 carbon, 1, 2, 3. And we know that this is aldose sugar. Aldose sugar will be having the functional group aldehyde. And keep in mind aldehyde will be perfectly on the first carbon. So we have to draw the aldehyde group on the first carbon in case of the glyceraldehyde. And aldehyde group will be having C double bond O and H. So CHO is the aldehyde functional group. Okay. So first carbon now filled with the functional group aldehyde because glyceraldehyde is an aldose sugar. Now the second carbon you can just fill with the HOH. Whatever the intermediate carbon is there, first carbon, ultimate carbon, whatever happens in between, it will be HOH. OH and H position will be varying, but ultimately it will be 2 valency of the carbon, in between will be filled always with the H and OH. So remember that particular. So H and OH. Now the last carbon. What are the valency? How many valencies remaining for the last carbon? 1 valency is already filled with this particular carbon. So remaining is 4. As a result, we can see that you have to first fill with HOH. So remaining is not 4, remaining is 3. So because 1 already it is filled. Okay, so now the remaining is 1. The remaining you can just fill with the H. Okay, so that is the ultimate practice. Wherever the balance is remaining, normally you will be filling it with the hydrogen. Okay, so now the structure of glyceraldehyde is ready. So this is the structure of glyceraldehyde. Now let us see the structure of dihydroxyacetone. We know that this also contains how many carbon? 3 carbon because both glyceraldehyde and dihydroxyacetone belongs to triose sugar. So 3 carbon is there. Now keep in mind it is ketose sugar. So keto group is there. You have to keep in mind, we have to remember that the keto group is always in the second carbon position. Aldehyde group is always in the first carbon position, but keto group is always in the second carbon position. So double bond O. This carbon valence is filled. 1, 2, 3, 4. Okay. Now the 2 carbon is there. First carbon and the ultimate carbon is there. We know that first you have to fill with the HOH. 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 Now this carbon, 1 valency is remaining, and for this carbon also 1 valency is remaining. We know that the remaining valency can be filled with the hydrogen. So you can just fill the hydrogen there. And this is the structure of dihydroxyacetone. Okay, so now you are familiar with the structure of glyceraldehyde and the structure of dihydroxyacetone and the way how to draw that particular structure. It's easy to remember. You have to remember what first, it's a triose sugar. So draw 3 carbon. Second, this one is aldose sugar. Aldose sugar will have aldehyde group. So it should be on the first carbon. So you are just drawing the aldehyde group. Now, second thing is always fill the carbon first with HOH. So you are just filling HOH. Because this valence is filled. Now this here HOH. This valence is one valence is remaining carbon. So remaining you can fill with the hydrogen. So see, so that is the structure of this particular thing. In the same way, dihydroxyacetone, it's a triose sugar, 3 carbon, 1, 2, 3. It's a keto group. So keto group is on the second carbon. So you fill the remaining carbon first fill with HOH. Then remaining valence fill with the hydrogen. So that is the structure of this both. Now what is actually the functional role played by glyceraldehyde and dihydroxyacetone? Actually, it is functioning as the metabolic intermediate. Metabolic intermediate. Okay, metabolic intermediate. So glyceraldehyde and dihydroxyacetone has metabolic function. It plays a role in metabolic intermediate in different metabolic reactions. For example, if you are taking glycolysis, we can see that in case of the glycolysis, glyceraldehyde 3-phosphate is converted or interconverted to dihydroxyacetone phosphate. Dihydroxyacetone phosphate or dihydroxyacetone phosphate will be converted to glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate is nothing but a phosphate group will be attached to this particular carbon at this position. And in case of this, at this position there will be a phosphate group. We have already learned what is phosphate group in buffer, the phosphoric acid. So it will be nothing but O, P, double bond O, O minus, O minus, where this O will be linked with this carbon. That is what phosphate. Okay, so glyceraldehyde 3-phosphate and dihydroxyacetone phosphate are the derivatives of glyceraldehyde and dihydroxyacetone, and they plays a major role in metabolic intermediate, metabolic pathways. Now we can see that this glyceraldehyde can form glycerol. So glycerol is formed from glyceraldehyde, or the glycerol can be converted into glyceraldehyde. How? So glycerol is nothing but CH2OH, CHOH, CH2OH. So what is the change here? CHO changed to CH2OH. What is added there? 2 hydrogen is added. So addition of hydrogen is actually reduction. So glyceraldehyde undergo reduction to form alcohol known as the glycerol, and the glycerol undergo oxidation to form the glyceraldehyde. So glycerol is formed from this particular thing, and this glycerol can act as an intermediate compound in case of the fat biosynthesis, the synthesis of fat, triglyceride. So these are the functions of this particular triose sugar. Okay, so keep only the one point, it acts as the metabolic intermediate and takes part in different metabolic reactions that is happening inside the body. Example is glyceraldehyde 3-phosphate, dihydroxyacetone phosphate, conversion of glyceraldehyde to glycerol and then to triglyceride, etc. Now let us move to the Tetrose sugar. Okay, Tetrose sugar, only one example you have to learn, and that is nothing but the erythrose. So erythrose you have to learn. Erythrose you have to learn. Erythrose. Okay, so erythrose, we know that it becomes the Tetrose sugar. What is tetrose? Contains 4 carbon. So we can just convert, write 4 carbon. 1, 2, 3, 4. And erythrose, it is aldehyde sugar. Erythrulose is keto sugar. You don't have to learn that. Erythrose, aldehyde sugar. So what will be there in the first carbon? It will be aldehyde group. C double bond O. Okay, now remaining all carbon you have to fill with what? HOH. So just fill HOH. Now the last carbon, ultimate carbon, one valency is remaining. And we have to make up that valency with what? Hydrogen. So this is what the structure of erythrose is. So easy to remember. So you have to keep only 2 things there. What are they? It contains 4 carbon. The first carbon is aldose aldehyde group because it is aldose sugar. That's all. Nothing else you have to remember. The entire content will be like this. Okay. Now what is the functional role played by the erythrose? The erythrose is actually playing a major role by converting into a derivative called erythrose 4-phosphate. And you can easily draw the structure of erythrose 4-phosphate. You just try it, okay? Because you just want to add a phosphate group at this particular carbon. That is what erythrose 4-phosphate. We have just learned glyceraldehyde 3-phosphate. In the same way, it is erythrose 4-phosphate. You don't have to remember the structure of this thing for the examination. Instead, you have to remember only this. But try to draw that and try to avoid your worry about biochemistry. Okay, when you are fixing a problem, definitely that if you are phobic about biochemistry, that will be gone. So you can just try to draw the structure of erythrose 4-phosphate. Anyway, this erythrose 4-phosphate is actually playing a role. So in where it will be playing. So you can see that in case of the Calvin cycle. So this erythrose 4-phosphate become the metabolic intermediate only. So this one is also functioning like a metabolic intermediate. Metabolic intermediate. Okay. And we can see that it is metabolic intermediate in Calvin cycle, then pentophosphate pathway, pentose phosphate pathway. You will be learning in metabolism. This you will not be learning because it's a part of the photosynthesis. Okay, Calvin cycle that you can learn from grade 12 book, or you can just check my grade 12 lessons. So pentose phosphate pathway. Now you can see that it is also acting as a resource or acting as a precursor for the biosynthesis of vitamin B6 and also precursor for the aromatic amino acids like tryptophan, phenylalanine, etc. So these are the functional role played by the erythrose in the form of erythrose 4-phosphate, a derivative of erythrose. Okay, now let us move to the pentose sugar, and you have to learn only one pentose sugar, that is nothing but the ribose. So let us see the ribose then. So pentose, and in that we are learning about ribose. So the structure of ribose we have already learned, because when we are discussing about epimers, ribose and arabinose linear structure we have drawn. Anyway, I am repeating it here. So you can see that ribose is composed of 5 carbon because it is pentose sugar. So 1, 2, 3, 4, 5. And then we know that the pentose ribose is actually an aldose sugar, and therefore we can just draw the aldehyde functional group on the first carbon. And the remaining carbon you have to fill with the HOH, 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 and H. This is actually the ribose. Okay, so this is the structure of ribose. But At the same time, as ribose is important component of the molecule DNA and RNA, we have to learn the ring structure of ribose. Okay, so what is the ring structure? Let us see. So in case of the ribose, it will be forming a 5-membered ring. And that 5-membered ring is actually the furanose ring. The pyranose ring is actually the 6-membered ring that is formed by the glucose. And you can see the 5-membered ring that is formed by the ribose, and that is nothing but the furanose. Let us see that. For drawing that ring structure of ribose also you have to learn. So you can just see this particular thing. Whatever there on the right side of the molecule, you just keep it on the top. And whatever there on the left, you just keep it on the bottom or the below the plane of the molecule. That is a simple way to remember the structure. So you can see that it is a pentameric ring. So it will be having oxygen here, then 4 carbon. So each junction is actually representing the carbon. Now the first carbon, H on top, and this oxygen will be combining with this hydrogen when ring structure is formed, so it will become OH. Now take the case of second carbon. What is there on the right side? H. So you just draw a hydrogen on top and then OH on the below brain. Now in this case also hydrogen on right, therefore on top, and OH below. And in this case, what is the? You have to form a bend. Ultimately, this is there on top. So CH2, no. First one. 1, 2, 3, 4, 5. Okay. So what is the 1, 2, 3, 4, 5? So CH2OH will be there on the top and H will be down. So 1, 2, 3, 4, 5 carbon. So this is the furanose ring structure of this particular ribose sugar. Okay. Now there are 2 forms of ribose sugar. We know that alpha and beta. What are alpha and beta? What is this actually? Just tell. Before I tell, you can just predict what is this, alpha or beta. Yes, it is alpha because OH is down. Okay, when it will be beta, when this OH goes up, it will be beta. So when we consider the function of ribose, we know that it is a major component of nucleic acid. And in case of the nucleic acid, there are 2 forms of ribose sugar that is present. That is deoxyribose and ribose. We know that deoxyribose will be present in case of the DNA, and ribose sugar will be present in case of the RNA. Now we should know which ribose, which anomer, alpha or beta anomer is present in case of the nucleic acid. It is actually the beta anomer that is present. So I am just changing this into beta form. So this is OH, H. So beta anomer will be present in case of the ribose that is there in the nucleic acid. Now let us see what is actually meant by the deoxyribose in DNA and the ribose sugar in RNA. Okay, actually this deoxyribose is adding values to the DNA in its stability. We know that DNA is more stable than RNA because of one factor. There are so many factors, and in that one factor is nothing but this deoxy, the lack of oxygen. Okay, let us see where this particular oxygen is absent. It is actually in this particular second carbon. So the 2-OH will not be there. Instead, only hydrogen will be there in case of deoxyribose. So this is actually deoxyribose. So keep in mind this particular thing. This is actually the deoxyribose, where the 2- or the second carbon oxygen is absent, and instead of hydroxyl group there will be only hydrogen. That is why it is known as the deoxyribose. So this one is actually the deoxyribose. Now let us see what is ribose. When this particular OH is retained there, it will be ribose. So this is beta deoxyribose, and we can just draw the beta ribose in this way: OH, H, H, OH, H, OH, H, CH2OH. So this is actually the beta ribose. Okay, so keep in mind this particular carbon second is actually mean for this beta and beta deoxy and beta ribose sugar. Okay, hope it's clear for you. So you have to keep these structures in mind, because ribose is the part of nucleic acid and you have to learn the DNA structure later in the upcoming unit. So at that time also we'll be repeating the same thing. So keep in mind which kind of pentose sugar is present in DNA and RNA. Okay, hope it's clear for you. So what is the major role played by the ribose? It is the major structural component of the DNA. It can be in the form of deoxyribose in DNA, or it can be in the form of ribose sugar itself in case of the RNA. So structural component of nucleic acid is the main role played by the ribose. Okay, so this also plays a major role in some other metabolic pathways. So ribose can also be considered as a metabolic intermediate in addition to the structural role played in case of the nucleic acid. So we can just add a metabolic intermediate also. Okay, metabolic intermediate. Now I'm just adding one more thing. This will be the part of structure of DNA. We know that there is 5' and 3' and that you have learned in case of the DNA. This is nothing but the carbon number of ribose sugar. So in case of the DNA 5' and 3'. So 3' is this particular position and 5' is this particular position, because we know that this is the 3rd carbon and this is the 5th carbon. When this 5th carbon OH is not involved, 5th carbon is not involved in any bonding with the next nucleotide, thus N will be 3'. If this 5th carbon is not involved in any bonding with the next nucleotide, this will be 5'. Okay, this is actually nothing but the carbon number present in the ribose. We will be discussing that in detail when we discuss the structure of DNA and all. So that's about the monosaccharide, triose, tetrose and pentose. In the next lesson we will be learning about the hexose sugar, glucose and the fructose. That is more important, and we will be just discussing the function of those two also. Okay, hope this lesson is clear for you. Just revise and learn one more and watch one more, and make sure that you have learned this particular topic, and then only you are moving into next lesson. And you can just comment, you can just add your doubt in the comment box, and I will be just replying to that. So that's about it. Thank you for watching.